so we are going to look at the last section in Unit 2. So we are almost done. Next week we will be reviewing and taking a test. Today we're going to be talking about Section 2.8, so graphing linear and absolute value inequalities. So we've already graphed linear and absolute value equations, yes? We're just adding another step to it. So with inequalities, a linear inequality resembles a linear equation, but with an inequality symbol instead of an equal sign. A boundary line is a line or curve that separates the coordinate plane into two regions. So, when you have less than or equal to, we are going to shade our graphs below the line. Now, if it happens to be vertical, we're going to look at numbers that are less than. So if it's vertical, it would be to the left, right? You're going to shade to the left because numbers that are left are less. Yes? For greater than or equal to, we would shade above the line. And again, if it happens to be a vertical line, you would shade the larger numbers, which are to the right. Now, if you have less than or greater than, you notice neither one of those are equal to, right? We normally denote those with an open circle or a parenthesis, yes, in interval notation. So on our graphs, we are going to use a dotted line to express this. If it's less than or equal to or greater than or equal to, we are going to express these with a solid line. So let's do a couple. Looking at example 1. In order to graph this, if this was an equation, we would want it in slope-intercept form. Do you agree with that? So we could graph the y-intercept and then the slope. So let's get this into slope-intercept form. What would we need to do to get that into slope-intercept form? Yes, subtract x to both sides. That gives us negative 2y is less than negative x plus 4. And then what would we have to do? Yeah, if we need y by itself, we divide by negative 2 to everything. Here's the thing. With an inequality, remember when we were solving inequalities before, what happens when you divide by a negative? You change the inequality symbol. So it would be y is greater than, a negative over a negative is a positive 1/2 x. 4 divided by negative 2 is minus 2. So, what is the slope of this graph? 1/2. What is the y-intercept? What do we graph first? The y-intercept, negative 2. And then from that point, we would go up 1 and right 2, right, because it's positive slope, correct? Up 1, right 2, down 1, left 2. And then here's the thing. This right here tells us it's going to be a dotted line because it's not equal to. Do you agree? So we start with a dotted line. It also tells us it's greater than, so we would shade where? Above. So we simply shade above this line. What that tells us is that every point in that shaded region should satisfy the inequality. So if you want to check yourself, I would pick a point in there, and the easiest point, if it is in your shaded region, would be 0, 0, right? So if we check it, we could check it with the point 0, 0 by plugging it into our original equation. So when x is 0 minus when 2 is 0, is this less than 4? Well, that would be 0 is less than 4, so sure enough, right? That's a good way to check to make sure you've shaded in the correct area. All right, let's do another one. Let's look at A. What do we do here? Yeah, we got to solve for y, so we subtract 3x. Here we have 1/2 y is less than negative 3x plus 2. What would we have to do now? Divide by 1/2 or multiply by 2. So we didn't multiply or divide by a negative, so our sign doesn't change. We still have less than. Here we distribute in, we would have negative 6x plus 4. Everybody agree with that? All right, so there's our equation. What is our slope? Negative 6 over 1. Your y-intercept is what? Yes. So we need to graph that, right? What do we do? Where do we start? No, we go up 4 first, right? You got to do your y-intercept first. So up 4. From that point, we graph our slope. Do you agree? So you could go up 6, left 1, but it doesn't really fit on there, does it? So I would go down 6, right 1. Now, this symbol tells me it's going to be a dotted line. Do you agree? And it's less than, so we would shade below the line, yes? All right, so dotted line here. Where do you think the below is? Here or here? Yeah, it's going to be where that line is tilted, right? So we think it should be over here. So we could check it by plugging in a point. How about we plug one in here like that? That would be the point left 2, 0, so negative 2, 0. So we plug in when x is negative 2, you'd have 3 times negative 2 plus 1/2 times y is 0. Is this less than 2? Well, 3 times negative 2 is negative 6 plus 0. That's less than 2, isn't it? Because it's a negative number. So we've got our graph correct. Let's look at B. What would we do here? All right, add x. So we have 2y is greater than or equal to x plus 4. What would we do now? Divide by 2. And we would get y is greater than or equal to 1/2 x plus 2. 4 divided by 2 is 2. What is the slope of your line? What is the y-intercept? All right. So what do we do? So first thing we do, is we go up 2. And then from that point, we graph our slope. Do you agree? Which tells me I would go up 1 and right 2. You could continue going up 1, right 2, or down 1 and left 2, correct? Now, here this is equal to, isn't it? So if it's equal to, that tells us it's going to be a solid line. And because it's greater than, we would shade above. So we graph our line, we shade above, and then we would need to pick a point. I'm going to pick this right here. Let's see, what is that? 0, 1, 2, 3, 4. To check it. So we plug in 0 for x plus 2 times y is 4. Is this greater than or equal to 4? Well, 2 times 4 is 8, and 8 is greater than or equal to 4. So it appears that we have graphed it correctly. One tutoring company advertises that it specializes in helping students who have a combined SAT verbal and math score of 900 or less. Write an inequality to describe the combined scores of students who are prospective tutoring clients. Let X represent the verbal score, and let Y represent the math score. Well, what does it tell us about those? It's combined to be 900 or less, correct? So what would we do here? Thank you. So if we're combining them, what do we do with them? Add them. And it's X and Y. So we add X and Y, and what does it tell us? It's got to be 900 or less. So what sign do you think we should put in there? What symbol? So less than or equal to 900. Does a student with a verbal score of 480 and a math score of 410 fit the tutoring company's guidelines? How would we check that? What would we do? You would add them together. So we would substitute it in 480 plus 410. We want to know, is that less than or equal to 900, don't we? So add those together, what would we get? 890, is that less than or equal to 900? So, yes, the combined score is 890. Okay, that's the linear. We still need to do the absolute value. Oh, one more word problem real quick. Let's practice this one. Manuel has $15 to spend at the county fair. The fair costs $5 for admission and 75 cents for each ride, 25 cents for each game. Write an inequality and draw a graph. We're not going to draw the graph. We're just going to write the inequality. That represents the number of rides R and number of games G that Manuel can buy. So first of all, we know that R is the number of rides. We know that G is the number of games. But what else has he already spent? He spent $5 plus, what about this one? What's it going to be? 0.75. You've got to start with 0.75 times R plus what else?
0.25
0.25 times G, it equals 15, or it must be less than or equal to 15. So the only other thing that I would expect is for you to move that 5 over, because we know we can combine that. So together, the rides and the games can cost no more than $10. Do you agree with that? Okay, let's look at example 3. If this was an equal sign, what would we know about this? It's absolute value, which means it's a V, right? So we know it's going to be a V, and what would that -2 tell us?
It's going down.
That it was moved down 2 units, correct? All right, so we wouldn't necessarily have to have a table for that one, would we? So we know it's a V that's moved down 2 units. Do you agree with that? This right here tells me it's going to be a solid line. And because it's greater than, I would shade above. Yes? So I could just actually put that on here, couldn't I? I know if it's moving down 2 units, 0, 0 would move down 2 units. And then I would move this one down 2 units. And so it's going to look, except for it's solid. Sorry, I was drawing a dotted line there. It's going to look like that right there, and then I shade above, which would be inside that V, wouldn't it? Now I could check it by picking a point. So if I pick that point right there, that's 0, 0, isn't it? So I'm going to check 0, 0. So if I plug that in, my y coordinate is 0. Is this greater than or equal to the absolute value? My x coordinate is 0 minus 2. Well, is 0 greater than or equal to the absolute value of 0 is 0 minus 2? Is 0 greater than -2? 0 is not greater than -2? Yeah, it is, right? Now, when we look at these extra practice ones, the problem is what?
You don't want to do it because it's extra.
Okay, well, that's not going to work here. Yeah, we know it moves up 3, but this 2 in front of there would have been a shrink or stretch, right? And so we can't really do it with translations. So that means we need to have a table of values here. Now, you could do that by hand, and let's do this one by hand. We know that the shape of this is a V, yes? We know that V shape is going to be on the x-axis, just moved up 3, and then we're going to have to shrink or stretch it, which means it's either going to be narrower or wider. So if it's on this y-axis, we need some negative numbers and some positive numbers. Do you agree? So I know that my initial point is going to be moved up 3 points. I know that. That's where my vertex is going to be. So I need to plug in some negatives and some positives. So I plugged in -2, -1, 0, 1, and 2. If we plug in -2 here, we would have y is less than or equal to 2 times the absolute value of -2 plus 3. Well, the absolute value of -2 is what? So we would end up with 4 plus 3, wouldn't we? Which is 7. So I would go left 2, up 7. If we plug in -1, we would have y is less than or equal to, we're plugging it in for x, 2 times -1 plus 3. Well, that would give us 2 times absolute value of negative 1 is 1 plus 3. And 2 plus 3 is 5, right? Again, we know it's starting at 3, but if you plugged in 0, 2 times 0 plus 3 is 3, yes? And then if we plug in 1, we would have y is less than or equal to 2 times the absolute value of 1 plus 3. Well, that would give us 2 times 1 plus 3, which is 5. So we go right 1 up 5. Could have gone left 1 up 5, sorry. Didn't plot that point. What do you suppose 2 is going to be? It better be 7, otherwise we got a problem, right? Now, looking at this symbol, this tells us it's a solid line. And it's less than, so we shade below, correct? So here we have a solid line. And we're going to shade below. And again, you could check a point in there. So we could check the point 0, 0. If we plug in, you'd have 0 is less than or equal to 2 times the absolute value of 0 plus 3. Well, that tells us 0 is less than or equal to 0 plus 3. That's a true statement, isn't it? Okay, let's do one more like that, and we can use our calculator on it. First of all, we know this one's moved, what? Left 1? Do you agree with that? So you know that it's going to move left 1 unit. So automatically, if I didn't have a calculator, I know that I need to go left 2, so that would be 2, 3, negative 3, negative 2, negative 1, 0, 1. Yes? Because my vertex is going to be right here. Correct? But you can graph them on your calculators. To graph them, remember, you go to y equals, and you can use the apps on your phone if you're at home, yes? So you go to y equals, alpha y equals over here to absolute value. Or if you don't have that option, you can go to math and over to number and absolute value. Except for we need a 3 in front of there. So 3 absolute value of x plus 1. Now we can't really graph that inequality. You can, but we're not going to worry about that. It's going to look like this, and then we have to deal with our shaded stuff, right? Now if you want the table from your calculator, you do second table, and you can plug in whatever numbers you want. So when I plug those in, I get 6 for negative 3. I get negative 2, 3, negative 1, 0, 0, 3, and 1, 6. And then I can transfer those over, yes? So I go left 3 up 6, left 2 up 3. We've got 0, 0, over 0 up 3. Right 1 up 6. Now this tells me that it's going to be a dotted line. And it's greater than, so we would shade above. So shade above means we would shade in here. Yes? Okay, and you could pick a value in there and check it if you wanted to. That is what we're doing today. Now real quickly, I want you to think about this. If you were given the absolute value of 2 minus x plus y is greater than negative 1. We need y by itself, don't we? to start that? And so if we need y by itself, you can subtract that entire absolute value to the other side. So that means you would have y is greater than negative absolute value of 2 minus x and minus 1. So I want you to know that these two are the exact same things. It's just manipulated.